In this video, we're going to learn how to write the SPD electronic configurations for different atoms. And in order for us to be able to do that, we need to know the order that the energy levels and that the sublevels fill up. So there's a rule that says electrons always enter at the lowest available energy level. Okay, you can see that here. This is in red. And this is what I would call rule 2 for writing electronic configurations. We're going to call this rule 2. Now it's known as the Aufbau principle. So it's obviously named after somebody whose second name was Aufbau. And we do need to remember which rule goes with which person. So the Aufbau principle says that electrons always enter the lowest available energy level. That's not really new for us, but I suppose it's the first time we've seen it being called the Aufbau principle. We have seen before that a rule that Bohr figured out that electrons always occupy the lowest available energy level. This is kind of an expansion of that when we're talking about the SPD electronic configurations. So that's the Aufbau principle. So why am I skipping straight to rule number 2? Well, we've done rule number 1 earlier up above here, and that is this one here. Where is it? Here we go. And that is orbitals can hold 2 electrons of opposite spin. Sorry, my tablet's got a mind of its own. That's what we call rule 1, and this is what we call the Pauli exclusion principle. So again, when we were talking about orbitals, we learned that they can only hold up to 2 electrons, any orbital 2 electrons. The opposite spin thing, I don't want you to worry too much about that. We'll see that in a later video. But orbitals can hold 2 electrons of opposite spin. This is the Pauli exclusion principle. That's rule 1. And then the second rule so far is that electrons always occupy the lowest available energy level. So what order do they fill up in? If they do occupy the lowest available energy level, well, what are the lowest available energy levels, and what's the order then as we go up? Which one is the next highest, the next highest, the next highest, and the next highest? Well, orbitals do not always fill up the exact way you would expect. So I'm reading from here. It says, remember when we learned about the sublevels, we learned that the 4s sublevel is lower in energy than the 3d sublevel. That was a little kind of funny thing we explained here earlier. So we need to take that into account when we're writing electronic configurations. There's 2 ways I'm going to show you that you can remember this. The first one is kind of a memory gimmick. And because of that, I don't really like memory gimmicks. I prefer us to understand what's going on. Sorry, I just need to rub this out because I've done this earlier from an earlier class, but I do want to get rid of this diagram because I want to draw it from scratch again for you guys. So give me 1 second. I thought I had this done. Please ignore that. Okay, we're going to delete that. I'm going to start again. Right. The first one is kind of a memory gimmick. And what we do here is we write down the different energy levels. N equals 1, N equals 2, N equals 3, N equals 4. And we're going to go to N equals to 5 and we'll stop there. N equals to 5. Okay, and we know that as we go to higher energy levels, as we move down here, the amount of energy is increasing. Okay, so the energy is increasing as we go up in energy levels. The next thing we want to do is we want to write down what sublevels are within those main energy levels. Well, the N equal to 1 just has 1 sublevel and we call it the 1s. The N equal to 2, we have an S sublevel and it's called the 2s because it's the second energy level. And there's also a P sublevel, which is called the 2p. The N equal to 3 has the 3s, the 3p, and the 3d sublevel. N equal to 4, 4s, 4p, 4d, and it also has a 4f. We're not going to worry too much about s for leaving cert, but be aware that it's there. And then in the 5th energy level, you got 5s, 5p, 5d, and 5f. Okay, someone has figured out that actually there's a little way of remembering. It's kind of a gimmicky thing. This is why I don't like it. But if you draw an arrow diagonally like that through the 1s, that's the first sublevel that gets filled. And then you draw arrows parallel to this arrow. So the next one would be here like this. So the second sublevel to get filled up is the 2s. Then draw another arrow parallel with this. So the next one is the 2p and then the 3s. And then the next one you do, another arrow parallel, the 3p and then the 4s. And the next arrow is parallel, the 3d. So this is how this helps you remember because it's showing you that the 3d is filled after the 4s because the 4s was done here and 3d is next. Okay, so you see that. This is kind of a way of remembering that little thing that the 3D gets filled after the 4s because it's higher in energy. Then the 4p, then the 5s, and so on. And you can continue that, blah, blah, blah. Okay, so that's a little memory gimmick, but it doesn't really, in my opinion, help you to understand why that is. To me, it's easier if we use the periodic table instead, okay? Because you will have this in the exam, whereas you won't have this in the exam. So this is something else you have to remember. If that works for you, you can use that. Now, you remember before in a previous lesson, we looked at the different blocks on the periodic table. We said that this block here, these two groups, is known as the S block. There to there. So all those elements are the S block elements. Then we had all of this block in here. This is the D block elements. And then finally, this one from here to here, these are the P block elements. So that's not new for us. We can use kind of the periodic table to help us figure out the order that they get filled in. Okay, so we know that this first line here, okay, this shows us the N equals 1 energy level. The next low line, the next period, well, this shows us the N equals to 2 energy level. And N equals to 3, and so on. N equals to 4. And we're not going to worry about the next one. It would be N equals to 5, but okay. And then if you use your periodic table, you can work out what order do they go up in. So obviously, this is the first element, hydrogen, and this is the second element. Both of these, their electrons are in the 1s sublevel. Okay. The next, if we had an element with 2 electrons, we see that they would go here and here. So that would be the 1s sublevel. A third electron, say we were talking about lithium. Lithium has 3 electrons. Well, therefore, it would have 2 electrons up here in the 1s. And the next thing to get filled would be, well, we're in the second energy level. And this is the S block. So this is the 2s sublevel. And we know if we had 4 electrons, we'd be here. And if we had 5 electrons, well, that's boron. That's over here. So after the 2s, the next thing to get filled is the 2p. Okay, so all of these have electrons in the 2p. After that, where do we go then? We go to the next line, the 3s, because this is the third energy level, and this is the S block. So 3s. We then skip across here. Aluminium is next, and silicone, and all of them, they have electrons in the 2, and this is the P block. Sorry, 3. Sorry, it's N equal to 3, and it's the P block. So 3p. Once we get to the end of argon here, where do we go next? The next place we go is, as we see, we go from element 18 to element 19. We're now talking about potassium. So we're in the 4th energy level, and this is the 4, and this is the S block. So 4s is next. Then calcium has also got its electrons in the 4s. This is where it gets a little bit strange, okay? Because what we're in here now is this is in the 4th line, the N equal to 4, scandium, and it's the D block. But technically, this is the 3D block. So you might look at that and say, oh, well, why didn't they put it in the 3rd line on the periodic table? It's stupid that it's down there. Well, the reason why they put it on the 4th line is because it's higher in energy than the 4s. Okay, so this is 4s up to here. And the next one is actually the 3D. Okay, that's the next one after the 4s. And the reason for that is it's higher in energy than the 4s. That's why it's in the same line. Okay, it's a bit silly. All right. And then you go down here. So you fill up the 3D. All of these have electrons in the 3D. You get to here. And then we're back to the 4th energy level. And this is the P block. So 4p would be next. Okay. So that's really the order that we would write them in. If we were writing them in order of increase in energy, it would go like this. It would go 1s, 2s, 2p, 3s, 3p, 4s, 3d, and maybe 4p, but we wouldn't need to go any further than that. Okay, so that is the order that the orbitals get filled. And that's what the Aufbau principle says. Electrons always enter the lowest available energy level. So that's the order that they would get filled in. Now, let's try one of these electronic configurations. Say you were asked to write the electronic configuration of fluorine. Okay, so fluorine. The very first thing you got to do here when you get asked to do the electronic configuration of fluorine is you've got to go to your periodic table and find out how many electrons it has. So I need to find out how many electrons fluorine has. And what I'm going to do is I'm going to rub out all of this crap. So we have a nice clean periodic table again. Because the one you have in your exam will be a blank one. It won't have anything written on it, and you're not allowed to write anything on it. It'll be in your log tables. So just clean this all up here. Okay, and let's find fluorine. Well, fluorine is here. Okay, so you see I have colored it in red, and I see atomic number is 9, and that means it's got 9 electrons. 9 protons, 9 electrons. Okay, so what we now need to do is we need to show how the electrons are arranged. So what we would do here is we would start by writing down the symbol F equals, and we're going to show then the electronic configuration. All right, well, it's got 9 electrons. Okay, so where do they fill and what order do they fill in? Well, the first place electrons are going to go here is in the lowest available energy level, which is the 1s. Okay, so we would write that like this: 1s, and then there are 2 electrons in that sublevel. So we would put a little 2 as what we call a superscript, which is like a little number up high, kind of like squared or cubed. That's called a superscript number. So we say this is 1s2. Now, what does that mean? Well, the 1 here, the number, this always refers to the main energy level. Main energy level. The letter shown here as S, this refers to the sublevel we're talking about. And then the 2, the number up here, the superscript number, this refers to the number of electrons in the sublevel. Okay. Now, that's obviously only 2 electrons dealt with so far, and we know fluorine has 9. So we have 7 more left to put into energy sublevels. Okay. So what comes next? Okay. So once we're finished filling up the 1s, the next place is down here. It's the 2s. So 1, 2. This is the 2, n equal to 2, and this is the s block, as we know. So 2s, 2 is the next thing to fill up. That's 4 electrons. After that, then we move across here, n equal to 2, and we're in the p block. 1, 2, 3, 4, 5. And once I get to fluorine, I'm going to stop because that's how many electrons I've got altogether. So what is this? This is the second energy level 2. It's the p sublevel, and there are 5 electrons here. You can always check if you're right here by adding up these little numbers of electrons at the top, and you should get this number up here, 9. So 2 plus 2 plus 5 is 9 electrons. So I know I'm right. Okay, so it's 1s2, 2s2, 2p5. All right, at this point, we're going to pause and answer some questions. So I want you to look at questions 277 and 278. Pause the video and do them now. Okay, so hopefully you've managed to do these, and we are going to talk about the answers now. So A, what does the 1 in front of the S indicate to us? It indicates the main energy level. So you should have said main energy level. What does the S indicate to us? This indicates the sublevel that we're talking about. What does the superscript 2 tell us after the S tell us? This tells us that there are 2 electrons in that S sublevel. What is the shape of an S orbital? That's spherical. And which energy level has the highest energy? That is out of these ones, that is the 4th. So you should have said the 4th. Good. So you should be correcting them, or you should be either ticking them, or you should be adding corrections, changing your answer if needed. Right, 278. How many electrons can the following hold? The 2s orbital. All orbitals, no matter what shape they are, hold 2 electrons. Doesn't matter whether they're s orbitals, p orbitals, d orbitals. One single orbital always holds 2 electrons. The 4p subshell. The 4p subshell is a p sublevel. P sublevels are all made of 3 orbitals px, py, and pz. And if there's 3 orbitals, they hold 2 each. It's a total of 6 electrons. Any p sublevel always has 6 electrons. The 4th shell, well, in the 4th shell, we have the 4s, 4p, 4d, and 4f to give us a total of 32 electrons. Okay, if you're not sure about that, you need to go back and watch one of the previous videos when we looked at the different energy levels. A 3d orbital, well, it's the key word here is that it's an orbital. All orbitals hold 2 electrons. And then the second energy level is made up of a 2s and a 2p sublevel. So that's a total of 8 electrons. Good. Now I'm going to model for you one more electronic configuration. And the one that I'm going to do for you is I'm going to do silicon. The first thing you need to do for silicon is find out how many electrons it has. So go back to my periodic table, find silicon. I'm going to clean off all the black marks. Start again. So silicon with a red marker is here. There's silicon. So I have 14 protons, so therefore I've got 14 electrons. 14 electrons. Okay, so the next thing I want to do is write down my symbol. Si is silicon, and the electronic configuration of Si is going to be. All right, so let's start again. Let's show you again the process. So the first 2 electrons go in the 1s sublevel. 1s, and there are 2 here. 1s2. The next 2 go in the second energy level, and the lowest available one sublevel then is the 2s. So 2s2. All right, the next few then go into this sublevel, which is the 2p sublevel. The 2p sublevel can hold 6 electrons. Does it get full here? Well, I've got 2, 4, and 6 more now. That gives me a total of 10. And I need to get to 14 electrons. So yeah, this one does get filled, 2p6. There's still 4 left to go. So where do I go next? I go down here now to the 3. This is the n equal to 3 energy level. And this is the 3s sublevel. So 3s2. And I've got 2 left. Okay. And they go here and here. Now I'm up as far as silicon, and I'm going to stop. And this is the 3p sublevel that I'm in here. So I'm in the 3rd energy level, and I'm in the p block. So this is the p sublevel, and there are 2 electrons in it. So this is 2, sorry, no, not 2. This is 3p2, like that. Okay, so that there is the electronic configuration for silicon. If you want to check, add them all up. So add all these numbers up and you should get 14. So 2 plus 2 plus 6 is 10, plus 2 and 2 is 14. And that's how you'll know that it's correct. Okay, so I also want you to write down beside them when you're doing these next ones, what block do they belong to? Well, here I can see, here's silicon and it's in the P block. So this is a P block element. All right, so you see here, this is what I'm asking you to do. Silicon is done for you. We just did that one. It's a P block element. What I want you to do is pause the video and do these ones now. Ignore the last one on the bottom line. We're going to do that separate. Okay, so pause the video and do them now. Okay, so you should only be watching the video if you have them done. I am going to go to a different screen now really quickly, and I'm going to show you what the right answers for this should be. Now you'll just have to bear with me for a second while I find them. Here we go. All right, so those are the answers. In red, you see here where I have worked out the number of electrons that each one should have, and I advise you that that's the first thing you should do. So the first thing is to check that you got all of them right. Sulfur, I don't know what, I think sulfur is 16 off the top of my head. And just check 2, 4, 10, yeah, 16. Okay, so you should have all of them done like that. And I think that's everything. Yeah, so check those. If you made any mistakes, go back and watch the video again to help you figure out exactly what order you need to do them in. If you didn't get these right, that means you need to watch it again. But hopefully you guys got the idea there and they're all right. All right, guys, so that's that. In the next video, we're going to look at a couple of strange ones that don't quite follow these rules, but that's it. You can now write electronic configurations.